Hi everyone, so welcome back to my channel Mathematic Girls Swati 3226. This is a practice video. I'm back with a practice video, and the topic, as you can see, the topic is integration. And in this particular video, I'm going to cover only short answer questions. So here I have written just integration and not specifically definite integration or indefinite integration. The reason is I'm going to, cover both the types. So there will be some questions which will be definite, some which will be indefinite. Okay, so let's get started with this video. And just a reminder, if you're new to my channel and you have not subscribed to my channel yet, don't forget to subscribe to the channel and share it with your friends and families as well. Okay, so let's get started with the first question. And the first question is, evaluate integration dx upon root over 1 minus x squared. We have to solve this. Now, this is a very simple question. This is actually a formula-based question where we can directly use the formula and we will get the answer. So let's see how to solve this. So yeah. So the formula here is that, the integration of, let me decrease the width. Yeah. Integration of 1 over root over 1 minus x squared dx. This has a direct formula and it is sine inverse x plus the constant of integration. So that is why using directly this formula, we can write down the answer is sine inverse x plus the c is the constant of integration. And that's the answer. So it was like a very short answer question, but yeah. So let's move to the next question. In the next question, we have integration dx over x square plus 16. Now, to solve this, what we are going to do is we are simply going to, convert this into the standard form. Okay, why into the standard form? Because if I convert it into the standard form, it is actually into a formula. So let's do that first. So integration dx upon x square plus 16. I can write down 16 as 4 square. Yes, of course. And now I'm going to use the formula. And the formula is 1 upon integration of 1 upon x square plus a square dx. This has a formula 1 upon a tan inverse x upon a plus the constant of integration, where what is a here? A is this one, right? So using this formula, what will this become? This will simply become 1 upon a, right? Here what is a? Here a is not 16, here a is 4, right? So therefore 1 upon a, that means 1 upon 4. Tan inverse x, right? So x as it is upon a is 4. So upon 4 plus c. So what is the answer? The answer is 1 upon 4 tan inverse x plus c. So these are the formulas that I'm using. So I'm just keeping it in a yellow, bubble. So yeah. Okay, let's move to the next question. And the next question, that is our third question, okay, is this. We have to integrate sec square 7 minus x dx. Okay. So let's solve this. So we have a direct formula for this as well. And the formula is integration of sec square x dx is equal to tan x plus constant of integration. Now using this formula, it will become tan x directly, right? But at the place of x, we have 7 minus x. So I'll write down 7 minus x plus c. But no, we are forgetting here one thing. Always remember that whenever we do the integration, whatever is the coefficient of x, we have to divide by that number, okay? So earlier you must have noticed that I did not mention any such thing because every time the coefficient of x was 1 only. So even if you divide anything by 1, no difference. That is why I did not pay attention to that particular thing. But here I'm going to pay attention for that because I can see the coefficient of x here is -1, right? Here it is minus sign. And of course, before x, no number is there. That means 1 is hidden, right? So therefore, it is actually -1. That is the coefficient of x. So that will come here, -1. Now, if you want, you can also write down simply this as minus tan 7 minus x plus c. And that is our answer. So, which is the formula? This is the formula that I used. Okay. Now we can go to the next question, that is the fourth question. So let's do the fourth question. Very simple question again. So yeah, let me write out the, okay. Sometimes it does happen, such things. Anyway, let's move to the fourth question. In the fourth question, we have to evaluate sec square root x upon root x dx, right? So here to solve this question, I'm going to substitute something. Why am I substituting here? Just to make my calculation easier. Okay. So let us substitute root x as t. Okay. So if I take root x as t, now I'm going to do the derivative on both the sides. Okay. So what is the derivative of root x? Root x is same as x raised to half, right? And we know that the derivative of x raised to n has a formula n into x raised to n minus 1. So if I'm doing derivative on both the sides, t will become dt and derivative of root x will become 1 upon 2, that is our n, x raised to n minus 1, that is half minus 1, that is minus 1 by 2. Now, using the property of exponent, I can write down this as 1 over 2 and this will become x raised to half, right? What is this property? The property is if we have e raised to minus m, that will become 1 upon e raised to m. This is the property of exponent. And then, of course, dx also, and then this is dt. Now, we can just rewrite down this as 1 upon 2. 1 second. Yeah. 1 upon 2, x raised to half is nothing but root x. Okay. This time also I was expecting this, but anyway. So 1 upon 2 root x dx is equal to dt, right? Now I can simply write down this as dx upon root x is equal to 2 dt. Now let's rewrite down the question. What was the question we had? Integration sec square root x upon root x dx, right? Now what I have taken this root x as t, right? So I can write down this as sec square t. Now, what is this dx upon root x? Can you see that we are having the same term over here? Dx upon root x, right? So at the place of this dx upon root x, I can put this value, that is 2 dt. So this will become into 2 dt. Now this is a constant. So of course this constant I can write down outside. So it will become integration of sec square t dt, right? Now this is a direct formula and the formula is integration of sec square x, right? So integration of sec square x, we all know it is tan x. So it will become 2 tan, at the place of x, of course, we have to write down here t only. So tan t plus the constant of integration, that is c. But what was t? T was nothing but root x. So it will become 2 tan, substituting the value of t, that is root x. So that will become 2 tan root x plus c. And that's the answer. All right, now we can move to the fifth question. So let's go to the fifth one. So in the fifth question, we have integration of dx upon x plus x log x. Okay. Now let's simplify this. So the very first thing that I can see that I must do is I can take this x common from the denominator, right? So this is dx as it is. Here if I take x common, and this will become 1 plus log x, right? Now we can write down this as integration. Okay. Instead of doing this, I can just see that if I substitute here something, I'll get, a simpler form. So here I'm going to put, let me take the smaller width here. Yeah. So if I took here 1 plus log x as t, and if I do the derivative on both the sides, so derivative of constant is 0. So 1 derivative is 0. Derivative of log x is 1 upon x. And then dx, of course, and this is dt. So what are we getting? We are getting 1 upon dx is dt. Now you can absolutely see that we are having this particular term over here, 1 upon x dx. So at the place of this, I can substitute dt. And 1 plus log x is already t. So what will this become? This will become integration 1 upon 1 plus log x I have taken as t. So it will become t. And then dx upon x, of course, it is dt. So it is dt. So what are we getting? We are getting 1 upon t dt. Now, we know that integration of 1 upon x dx is log mod x plus the constant of integration. So, using this particular formula, what will this become? This will simply become log mod t, right? Plus the constant of integration, that is c. But what is the value of t? The value of t we have taken here as 1 plus log x. So it will become log of mod 1 plus log x and then plus the constant of integration. And that is our final answer. So we are done with the fifth question. Now we can move to the sixth question. Now the sixth, all these integration that we were doing, these all are called indefinite integration. Now the sixth question is a definite integration. Now what is the difference between definite and indefinite? Indefinite, we have the limit given, okay? And indefinite, there is no limit given. So this particular question is a definite integration. So it is given if integration, definite integration from 0 to 1, 3x square plus 2x plus k into dx is 0, then we have to find the value of k. It's very simple, okay? Let's solve this now. So simply we have this, okay, so there is one rule that integration we can, like distribute, okay? So using that property, first of all, this will become integration of 0 to 1, 3x square dx plus integration of 0 to 1, 2x dx plus integration of 0 to 1, k dx is equal to 0. Now, what will this become? This is 3. If I do the integration of x square, there is a formula, and the formula I'm going to write down over here. Yeah. So this will become integration of x raised to n dx is x raised to n plus 1 upon n plus 1 plus the constant of integration. But here I'm not going to write down this plus constant of integration. Why? Because whenever we have the definite integration, in definite integration, we do not have the constant of integration. Okay. So this will become, this constant I have written outside, and using the formula, it will become x raised to n plus 1, that is 2 plus 1, that is 3, and then upon again the same thing, 3, and then the limit 0 to 1 plus, here 2 is outside, the, like integration of x will become, of course, x square upon 2, and then the limit 0 to 1. Here k I can write down outside because that is a constant, and integration of 1 is x, so it is x, and then of course 0 to 1, and then this is equal to 0. Remember, we have to find out here the value of k. Now we can simplify this further. First, what I'll do, I'll take all these constants outside the bracket, okay, because that is not doing anything inside. So this 3 into 1 upon 3, and then if I put the value of limit, remember how do we put the value of limit? We put the upper limit first at the place of x. So it is 1 cube minus lower limit. So 0 cube, that is it. Here also I'll take this 2, like 1 upon 2 outside, and here putting the upper limit, that is 1 square minus 0 square. And here also k, and putting the upper limit, that is 1, and then lower limit minus 0 is equal to 0. Okay. Remember how I'm putting the upper limit, lower limit, and just putting the upper limit at the place of x and minus the lower limit. Like at the place of x, I'm putting the lower limit. Now this 3 will get cancelled, this 2 will get cancelled. So what I'm getting, 1 cube, that is 1, 1 minus 0 is 1 only, so it is 1, plus 1 square, that is 1, 1 minus 0 is 1, so 1 only, plus k, 1 minus 0 is 1, k into 1 is k, so k is equal to 0. So what is this? This is 2 plus k is equal to 0. What is the value of k? The value of k we are getting is minus 2, and that is our answer. The value of k is minus 2. Okay, now we can go to the sixth question. I hope you are understanding all the questions. If there is any doubt, let me know in the comment section. I make shorts as well, so you can, like, let me know if any question you have not understood. I can make the shorts for that particular question, where I'll be explaining things in detail. Now let's go to the sixth question, and in the sixth question, we have to evaluate integration from 0 to 1 upon root 2, and then dx upon root over 1 minus x square. Let's simplify this. So this is a similar question that we did in the starting almost. This is a formula based question. So first of all, the formula I'm writing here, integration of 1 upon root over 1 minus x squared dx is sine inverse x. Okay. Here I'm not intentionally writing the constant of integration because this is a definite integration once again. So directly after using the formula, what are we getting? We are getting sine inverse x. But this time we are having the limit as well. So that is 0 to 1 upon root, right? So directly using the formula, we got this particular thing. Now, if I put the value of limit, so of course I have to put the value of upper limit at the place of x. This is sine inverse 1 upon root 2 minus sine inverse 0. Now here again, I'm going to use the formula, and the formula first is sine inverse. I can write down at the place of 1 upon root 2 sine pi by 4. Why sine pi by 4? Because sine pi by 4 is nothing but sine 45. Because if you put at the place of pi 180, 180 divided by 4 is 45. And the value of this is 1 upon root. So at the place of this 1 upon root 2, I have substituted this value. Okay. Minus sine inverse 0. We know that for what value of sine the value is 0, sine 0. So I can write on sine 0. Now here I'm going to use the formula, and the formula is sine inverse sine theta is theta. So using this particular formula, here theta is of course pi by 4. So sine inverse sine pi by 4 will become pi by 4 minus sine inverse sine 0 will become 0. So pi by 4 minus 0 is simply pi by 4. And that's the answer. Let's move to the next question. That is our 7th question. Okay, so in the 7th question, what do we have to do? The question is evaluate integration 2 to 3 1 upon x dx. Very straightforward question. So again, we are going to use the formula here, and that is 1 upon x integration dx is log x, right? Log x, log mod x. Okay, so I'm writing log x here. If you want, you can write a log mod x. So using that formula, it will simply become log mod x, but with a limit that is 2 to 3. Now, after putting the limit, it will become log mod 3 and then minus log mod 2. Here I'm removing the mod, and I can just write down this as log 3 minus log 2. So, okay. If you want, you can leave your answer here also. If you want, you can simplify it further, okay, by simply using the formula of log A minus log B. What is log A minus log B? The formula is log A by B. So using this formula, it will become log 3 by 2. And that's the answer. All right, now we can go to the 8th question. The next question, and let's write down the 8th one. All right. So in the 8th question, we have to simplify integration 1 minus x root x dx. Okay. Now, this is a very simple question, looks difficult, but not at all difficult. Using the property of like distributive property, I can multiply this root x with 1. What is 1 into root x? Root x. Minus this root x with x. So what is x into root x? Let's write down root x into root x now. Now, of course, we can write down this as x raised to half minus. Here using the property of exponent. This is x raised to 1 times x raised to half. Now, using the property of exponent, if we have the same base and they're getting multiplied, so the power will get added. So it will simply become 1 plus 1 by 2. So it is 1 plus 1 by 2. That is, of course, x raised to 3 by 2 after taking the LCM. So this will become x raised to 3 by 2 and then dx. Now we can distribute the integration. So it will become integration x raised to half dx minus integration x raised to 3 by 2 dx, right? Now we know the integration formula, x raised to n, integration x raised to n is x raised to n plus 1 upon n plus 1, right? And then plus c, of course, because this is again an indefinite integration because we don't have any limit. So this will become x raised to half plus 1 upon half plus 1 plus, we are having two constant of integration, so let's write down this as c1 minus, this will become x raised to 3 by 2 plus 1 upon 3 by 2 plus 1 and then plus the constant of integration 2. So let's write down this in bracket. Okay. Now, this will become x raised to half plus 1 if you simplify 3 by 2, and if you simplify this, it will become 3 by 2. Plus the constant of integration minus this will become x raised to 3 by 2 plus 1, that is 5 by 2, and this will become 5 by 2 plus the constant of integration, the second constant of integration. Now this will become, if you simplify this, it will become 2 by 3 x raised to 3 by 2 plus c1 minus x raised to 5 by 2, and this 5 by 2 will become 2 by 5, and then minus plus will become minus c2, right? Of course, we have removed the bracket, so minus into plus is minus. Now, I can just simply write down this as 2 by 3 x raised to 3 by 2 minus 2 by 5 x raised to 5 by 2, and this c1 minus c2 together, which we can also replace. So 2 by 3 x raised to 3 by 2 minus 2 by 5 x raised to 5 by 2, and at the place of the c1 minus c2, I can just use 1c, where you can just write down what is your c is nothing but 2 constants which we are subtracting, c1 minus c2. That is it. This is our answer, final answer. Okay, so this was our 8th question. Now let's move to the 9th question. So in the 9th question, we have a very famous formula that we are going to use. Let's do that question. So remember, all these questions I have chosen are very, very important questions. All these questions are from the CBSE sample paper. All these questions have come once or twice in a board exam. So make sure you just watch this video carefully. Let's do this question. Integration e raised to x root over 1 plus sine 2x upon 1 plus cos 2x dx. Okay. Now to simplify this, what are we going to do? Integration e raised to x, root. At the place of 1, I'm going to use a formula, and the formula is sine square x plus cos square x. We know that this is a very famous formula, sine square theta plus cos square theta is 1. So at the place of 1, I have substituted with the formula. Plus, I'm just writing the formula that I've used. So sine square x plus cos square x is 1. But there is one more thing, that is sine 2x. For sine 2x also we have a formula, and that is 2 sine x cos x. So using this formula, this will become 2 sine x cos x, right? Okay. And upon 1 plus cos 2x, there is a formula for this as well. We know that 1 plus cos 2 theta is 2 cos square theta. So this formula, using this formula, it will become 2 cos square. At the place of theta, we have x, so 2 cos square x dx. Now, this will become integration e raised to x. If you notice that whatever term we have inside the square root, that is actually satisfying the formula of a square plus b square plus 2ab. We know that a square plus b square plus 2ab is nothing but a plus b whole square. So using that particular formula, a is sine x, b is cos x. So it will become sine x plus cos x whole square upon 2 cos square x, right? Now, of course, this 2 that you can see in the denominator, that I can write down outside the integration as well. So it will simply become, okay, give me a moment. Yeah. So that 2 I can write down outside the, that 2 I can also write down outside the bracket. So it will become 1 upon 2 integration e raised to x. Here square root and square will get cancelled. So what we are getting? We are getting the sine x plus cos x. And then in the denominator, we are getting cos square x, right? Now what I'll do here, I'll distribute the LCM. So e raised to x, this will become sine x upon cos square x plus cos x upon cos square x. And then of course dx, which I'm forgetting to write. So remember dx also. Now, I'm going to use here some trigonometric formulas. Okay, so let's just simplify that. So this is 1 upon 2. Okay, this keep on happening. Let me fix that. Okay. Yeah. All right. So this will become 1 over 2. Then integration e raised to x. Here I can just write down this as sine x upon cos x into 1 upon cos x. Of course, that's the same thing. And here, of course, this cos x with the square will get cancelled. So we're getting just 1 upon cos x. and then of course dx. Now this will become 1 upon 2 integration e raised to x. We know the formula of sine theta upon cos theta. Very famous formula, sine theta upon cos theta is tan theta. So I'm directly using the formula. You make sure you write down the formula on the other side. And 1 upon cos x formula is sec x plus, this is again sec x by formula, and then dx. Now I'm just going to rewrite down this as integration e raised to x, and then this I'm writing as sec x plus this tan x into sec x, I'm writing as sec x into tan x, same thing, and then dx. Now here comes the formula. Now you must be wondering which formula I'm going to use. So let me tell you, this is a very, very important formula of integration, and it is also not a very difficult formula. Okay, so it's very straightforward. If you have integration of e raised to x, any function plus the derivative of that function, that means f dash x, then the formula of this is e raised to x into product of the function, that is this function, plus the constant of integration. So using that formula, you can notice that we are having e raised to x, the formula, fx, a function, and the derivative of this function, because we know that the derivative of sec x is nothing but sec x tan x. So we are having the derivative. That means it is satisfying this formula. That means it will have this formula. So e raised to x into fx. What is fx? Sec x. So e raised to x sec x plus c. So therefore the final answer is half e raised to x sec x plus c. This is our answer. All right, this was our 9th question. Let's move to the 10th question. Okay. All right. So we will be doing only 3 more questions. Okay. 3 or 4 more questions and we are done. So let's go to the 10th question. In the 10th question, we have to find integration minus pi by 4 to 0, 1 plus tan x upon 1 minus tan x dx. Okay. Now, what will this become? Simply it will become, like here we have to do something. We have to use some formula. So let's do that first. So integration minus pi by 4 to 0. At the place of 1, I can write on tan pi by 4. Why? Because we know that tan 45 is 1. And this is tan x as it is. This at this place, I'm writing 1 only, minus. If I just multiply 1 here with tan x, no difference, because 1 into tan x is tan x only, but it will just do a lot of difference because it is giving us a formula. At this place, like at this one, I can again write on tan pi by 4 and then tan x as it is. Okay, and then dx. Now, here I'm going to use the formula, and the formula is tan A plus tan B upon 1 minus tan A tan B. This is nothing but tan of A plus B. So using this formula, it will become tan of A, which is pi by 4, plus B, which is x dx. Now, we can just write down this as, okay, this will become integration minus pi by 4 to 0 and tan pi by 4 plus x, right? So here we are simply going to use the formula, and the formula of integration of tan x, okay? So we know we have a formula for integration of tan x dx, and that is log sec x, okay, plus the constant of integration, which I'm not going to use here because we are not having the indefinite integration, we are having a definite integration. All right. So now this will become, by using the formula, it will become log sec x. But what is x? X is here pi by 4 plus x. So we will write on that. And of course, the limit, that is minus pi by 4 to 0. Now, what we can write down? We can simply write down this as log. We will, of course, put the value of upper limit and lower limit. So log sec, this will become pi by 4 plus 0, and then minus log sec, putting the value of the lower limit, that will become pi by 4 minus of minus pi by 4, right? Okay, so yes, now we can write down this as log sec pi by 4 And then here it will become minus log. Okay, so one thing I missed here, that is log pi by, this is like log pi by 4 plus x, right? So here it is plus, right? Okay. And log sec pi by 4 plus into minus is minus, so minus pi by 4. And now simply this will become log, the value of sec pi by 4 is root 2, right? Because the cos pi by 4 is 1 upon root 2 and cos and sec are inverse, so it is root. So it is log root 2 minus, this will become log sec pi by 4 minus pi by 4, that is 0. Now, this is log root 2. But what is the value of sec 0? The value of sec 0 is 1. So it will become log 1. Because cos 0 is 1, so sec 0 is also going to be 1 by 1, that is 1 only, right? Now here, if you want, you can use the formula, and that is log A minus log B. By using the formula, it becomes log A by B. So using this one, it will become log root 2 by 1, which is same as log root 2. If you want, you can leave your answer here. If you want, you can simplify this further. I can write down this as log 2 raised to half. And there is a formula, and that is log A raised to B is same as B log. Okay, so whenever you are getting the expressions in, like in terms of log, always simplify this. So using this particular formula, here B is half, so half will come before log, and half log 2 is our answer. Okay, let's go to the 11th question. I can say the third last question, because after this we'll be doing 2 more questions and we are done. Okay, let's start. So the next question is integration. Okay, I'll just write down from here now. Integration dx upon root over 5 minus 4x minus 2x squared. And let's simplify this. Okay, so for that, I'm just going to write down this as integration dx upon, I can write down this 5 as 7 minus 2, right? Yes. And then minus 4x minus 2x squared as it is. Now in the next step, what I'll do, I'll write down dx upon root 7 as it is. Now from these 3 terms, I'm taking minus 2 common. If I take minus 2 common, what is inside the bracket 1? Because 2 times 1 will be 2. Plus, because I have taken minus common, so 2x plus 2 is outside, so x square only. Now, I hope you can, like, you have already observed what is happening here and what do we have to take, like, like what do we have to do inside the bracket. So let's do that. So dx upon root over 7 minus 2, and here I can write on this as x square plus 2x plus 1, I can write on as 1 square, right? Same thing. Now I hope you must have understood that it is nothing but it is the formula of a plus b whole square. A square plus b square plus 2ab, right? So using that formula, it will become simply x plus 1 whole square, right? Now, we can just write down here, we can simplify this by writing dx. I will be taking from this, like inside this root only, I'm going to take 2 common. So if I take 2 common, what I have to put here? 7 by 2, of course. So that it will be 7. And from here, I have taken 2 already outside common. So it will become just x plus 1 whole square as it is, and then bracket closed. Now, this I can write down as integration dx. There is one thing that you should know. If you have root ab, that we can write down as root a into root b also. So using that formula, I can write down root 2 and then into root over 7 by 2 minus x plus 1 whole square. Alright. Now, this we can write down as, okay, 1 second. Yeah. Okay, that was expected again. And okay, so this will become, I can just write down this 1 upon root 2 outside, and then dx upon, sorry, integration of dx upon root over, I can write down 7 by 2 as root over 7 by 2 whole square, that's the same thing, minus this x plus 1 whole square as it is. Why I did this? Because we have now this into the formula of integration of dx upon root over a square minus x square. And the formula for this is sine inverse x by a. So using that particular formula, it will become 1 upon root 2 as it is, and using the formula, it will become sine inverse. What is x? X is x plus 1. Remember, it is x, not x plus 1 whole square, because here x square has become x. So x plus 1 upon a. A is root 7 by 2. Okay, and then of course plus the constant of integration. So this will become 1 upon root 2 as it is. This root 7 by 2 I can also write down as root 7 by root 2. Here also root will get distributed, and if you simplify that, it will become root 2 over root 7. And this is sine inverse x plus 1 as it is plus c. Of course, this root and this root will get cancelled. So what is our final answer that we are getting? The final answer that we are getting here is, okay, one mistake. There is one mistake I have done. That is, this root 7 by 2 is in with 7, is with sign only, right? So I cannot write down that outside. Yeah, that was a mistake. And this is 1 upon root 2. If you want, you can simplify this, so it will become sine inverse inside the bracket only. We cannot cancel that root 2 and this root 2. Okay, so this will become root 2 over root 7, and then x plus 1 plus c. If you don't want to do this, you can simply keep your answer here. You can stop it here. Okay, otherwise you can write down this as well. Okay, this was our 11th question. Let's move to the second last question of the day, and that is integration 0 to 1 tan inverse x upon 1 plus x squared dx. Okay, now to solve this particular question, I'm going to substitute here something. Okay, so I'm going to substitute this tan inverse x. So if I'll substitute this tan inverse x with t, so let's do that. So let tan inverse x is equal to t. Now if I do the derivative on both the sides, tan inverse x derivative is 1 upon 1 plus x squared dx. This is by formula. Remember that? There is a formula of derivative of tan inverse x, that is 1 upon 1 plus x squared. And this is dt, right? There is one more thing that we have to do here. Because we have substituted the value of tan inverse x, we have to change the limit as well. So when x was 0, right? When x was 0, it was tan inverse x. But when now if we put x is equal to 0, what will be the value of t? The value of t will be tan inverse 0, right? Now what is tan inverse 0? Tan inverse 0 is simply, okay, I can just write down here, tan inverse, oh, give me a moment. So it will become tan 0 only, because tan 0 is 0. Now tan inverse tan theta is 0, so it is 0. So when x was 0, t is 0. So now the new integration will become 0 only. This did not get changed. But now when x is equal to 1, what will be the value of t? T will become tan inverse 1, which is nothing but tan inverse. At the place of 1, we can write on tan pi by 4. And we know that tan inverse tan theta is theta. So that will become simply pi by 4, right? So now the limit, upper limit has changed, that is pi by 4. And now tan inverse x I have taken as t, so this will become t. And then at this particular expression, we have the value dt, right? So this will become simply dt. Very simple now. Integration of t, we all know it is t square by 2. And now no constant of integration, because this is a definite integration. And now if I put the value of the upper limit and the lower limit, which is 0 to pi by 4. Of course, this 1 upon 2 I can write on outside. And this will become pi by 4 whole square minus 0 whole square. So it is simply going to be 1 upon 2 pi square, and 4 square is 16. So that is, and 0, no need to write on. So it will become pi square upon 2 into 16 is 32. So this is our answer, pi square over 32. Now let's move to our last question of this video, and that is our 13th question. Okay. So in this particular question, we have to evaluate 0 to 1 and then dx upon root 2x plus 3. Okay. Now to simplify this, we are simply going to use the property of exponent. I can write down this as 2x plus 3 raised to negative half, right? Using the property of exponent. Now I can directly use the formula, and the formula is 2x plus 3 raised to minus half plus 1, that is half, and then minus half plus 1 in the denominator, that is also half. And then of course we have the limit also, that is 0 to 1, and then plus the constant of integration, no, because this is a definite integration. Now this 1 upon 2 that you can see here, this will come outside, so it will come outside as 2 only, right? And now inside this we are getting, okay, one more thing here, what is the coefficient of x? 2, that should be divided, right? So if I divide that, this 2 will come over here, so this 2, that is, okay, 1 upon 2, if I just shift it outside, so it will become 2, and then this 2 also, so 2 by 2, and here we are getting just 2x plus 3 raised to half, which is same as this only, with upper limit and lower limit. All right, now we can simplify this. 2 upon 2 will get cancelled only. So now if I put the value of limit, it will simply become root over, okay. Yeah, so it will simply become root over the value of the upper limit, that is 2 into 1 plus 3, minus the value of the lower limit, that is 2 into 0 plus 3. So this is 2 into 1, 2, 2 plus 3 is 5, minus 2 into 0 is 0, 0 plus 3, so it is root 3. So what is the answer? The final answer we are getting is root 5 minus root 3. And that is the end of this particular video. I hope you understood each and every question. Do let me know your suggestions and your feedbacks in the comment section. I read each and every comment of yours, even in my shorts, like even on my shorts or on my long videos, everywhere. So thank you so much for supporting my channel, for loving me so much. I get a lot of responses. Thank you so much. I'm really grateful to all of you guys. So yeah, I'll see you super soon in my next video. Till then, bye, take care.